Hello my dear students, welcome to the ESE Engineering Academy online platform. I am Malakondaya Gandham, Thermal Faculty at ESE Engineering Academy. Dear friends, I have more than 25 years of experience in the teaching. Okay? In this platform, we are going to discuss the syllabus and preparation strategy on the subject thermal engineering for both GATE and ESE 2024. Okay? First, let us take the syllabus. Syllabus, going through the syllabus is very, very important. Most of the students are doing mistake here. They are not seeing the syllabus until they are writing the exam. That shows that is their negligence, irresponsibility. The preparation for GATE or ESE or for any other competitive exams without syllabus seeing means directionless preparation. Okay? Now let us take the syllabus for the GATE thermal engineering. There are different concepts like basics of thermodynamics, work and heat, first law of thermodynamics, second law of thermodynamics, entropy, availability, properties of pure materials, air cycles, psychrometry. Similarly, the Rankine cycle, gas turbine cycles, refrigeration, thermodynamic relations, reciprocating air compressors, and steam turbines. These are the topics which are included for GATE exam. Okay? Among these topics, dear friends, remember, the most important topics or most important units are steam turbine. From steam turbine, you can expect 2 marks. Okay? Similarly, the other important unit is refrigeration. From the refrigeration also, you can expect 2 marks. From thermodynamic relations and reciprocating compressors, you can expect 1 mark. Okay? Gas turbines and Rankine cycle, 2 marks can be expected. 2 to 3 marks can be expected from the Rankine cycle and gas turbine cycles. Similarly, from basics of thermodynamics, work and heat, 1 mark question can be expected. From both first law and second law, you can expect the minimum 2 marks, maximum 3 marks. 2 to 3 marks can be expected from both first law of thermodynamics and second law of thermodynamics. From entropy and availability, 1 mark can be expected, maximum 2 marks. From properties of pure substances, 1 mark can be expected. Air cycles, 1 mark to 2 marks can be expected. Psychrometry, 1 mark can be expected. That is the weightage of thermal engineering for the GATE exam. Total weightage, 10 marks minimum can be expected, maximum 15 marks. That is the weightage of thermal engineering for the GATE exam. Whereas for the ESE exam, in the prelims, 25 questions minimum expected. 25 questions can be expected from the thermodynamics. In addition to these topics or in addition to thermodynamics, for the ESE exam, you need to practice the power plant engineering, internal combustion engines, and refrigeration and air conditioning systems. Power plant engineering, refrigeration and air conditioning and IC engines, these are the extra subjects or extra topics to be prepared for the ESE exam. Okay. Now gate point of view, the best material or standard material is Engineering Thermodynamics by P.K. Nag. Dear friends, you just go through the theory concepts through this P.K. Nag. It is not advisable to prepare many textbooks. One standard textbook is more than sufficient. Here most of the students are doing mistake. What is that is, they are collecting the material which is available in the market, but no material is completely prepared. That is the main mistake the students are doing. One standard book is sufficient if you are not taking coaching in our academy. If you are taking the coaching in our academy, that is ESE Engineering Academy, you need not to go through any textbook. Whatever the notes you are taking from thermal faculty, that is more than sufficient. Of course, I am taking the all right thermal part in our academy. Anyhow, our classroom notes is more than sufficient. That classroom notes is the collective information of more than 10 standard textbooks. Okay? Then, GATE exam is the numerical type exam. 90% of the question paper is right with problems, numericals. From that you can conclude that the problem practice is very, very important. Without pen and paper work, calculator work, it is impossible to get the success in the competitive exams, particularly in the GATE exam. Therefore, problems practice is very, very important. Most of the students, what they are doing, just they are practicing the concepts and they are reading the numericals. It is not correct. Practice is very, very important. For having the best practice, I will suggest 3 materials which are available in our academy. First one is Thermal Engineering by Volume 1. From the each and every topic, from the each and every unit, from this material, at least you will find 30 questions. Okay? After practicing 30 questions from the each and every unit which are available in our material, then try to practice the questions from bits and bytes. These are very, very important questions. From the bits and bytes also, from each and every topic, you will find more 30 questions. More 30 questions. After practicing the volume 1 problems, bits and bytes problems, then volume 2 is available. From the volume 2, you can find more 30 questions from the each and every unit. More 30 questions. 30 plus 30 plus 30, 90 questions. That means you are going to practice 90 questions from the each and every unit. After practicing the volume 1, volume 2 and bits and bytes, then you practice the questions right from the previous year exams. From the previous year exams booklet, you can find at least 20 questions from the each and every topic. Then what are the total number of questions you are practicing from the each and every unit? 30 questions approximately from the volume 1, 30 questions from the volume 2, 30 questions from the bits and bytes on an average, and 20 questions from the previous year exams. Total 110 questions you are going to practice from the each and every unit, these are more than sufficient. You need not to go to or you need not to touch other material also. Volume 1 problems, volume 2 problems, bits and bytes problems, and the previous year exam papers. These are more than sufficient. On an average, at least you are going to find 100 questions from the each and every unit. That practice is more than sufficient to get the single digit rank in the GATE. Okay, like that you try to practice other subjects also. Our academy is providing 3 kinds of material. You try to practice all the problems. Most of the students, what they are doing is, they are studying the concepts, but they are not putting much time for practicing the problems. Without practicing the problems, it is impossible to get the good score or good rank in the GATE. Try to practice all the 3 volumes for the each and every subject if you want single digit rank in the GATE. Okay, then now look at the unit wise, chapter wise important topics. Chapter wise important topics. From basic concepts or basics of thermodynamics, there are different important topics like properties, okay, types of systems, differences between point function quantities and path function quantities. Okay, and try to study clearly the meaning of reversible process and irreversible process. So these are the important concepts you need to practice from the basic concepts of thermodynamics. Thermodynamic system properties like intensive properties, extensive properties. Types of thermodynamic systems. You might have studied open system, closed system, isolated system. You try to find the practical open system, practical closed system, and practical isolated system. Differences between the point function quantities and path function quantities, the reversible process and irreversible process. So these are the most important concepts from the basic concepts of thermodynamics. Similarly, from the second unit, that is work and heat, you try to practice the thermodynamic work for different process. Thermodynamic work for different process like constant volume, constant pressure, constant temperature, reversible adiabatic, polytropic. Similarly, you try to practice the heat transfer for all these processes like constant volume, constant pressure, constant temperature, reversible adiabatic, polytropic. Okay, so practice the work and heat. Practice work and heat for different thermodynamic process. Different thermodynamic process. Like constant volume process is also called isochoric process. Constant pressure process is also called isobaric process. Constant temperature process is also called isothermal process. Reversible adiabatic process is also called isentropic process, and the polytropic process. You try to practice particularly numericals for all these process. Anyhow, under work and heat, you try to practice the formulas and numericals right? For different process like constant volume, constant pressure, constant temperature, reverse adiabatic, polytropic, etc. Okay. Then the next unit is first law of thermodynamics. It is most important, right? You study, you try to practice the applications of, first law of thermodynamics. First law of thermodynamics. As you know, there are two applications from the first law of thermodynamics. First one is non-flow process. एक minute. Non-flow process. Non-flow process. You know, non-flow process means process in the closed system. Okay. The non-flow process are two types. First one, non-flow reversible process. Non-flow reversible process. Non-flow irreversible process. Non-flow irreversible process. The best example for non-flow irreversible process, Fourier expansion process. Okay. For all the non-flow process, the energy balance equation is what? The energy balance equation is called non-flow energy equation. That non-flow energy equation is Q equal to, right? Q equal to W plus du. Okay. You try to practice number of problems on that particular equation or non-flow energy equation. The second application from the first law is what? Flow process. Flow process. Flow process are two types. Steady flow process, unsteady flow process, unsteady flow process. Unsteady flow process example, bottle charging process, bottle discharging process, etc. Similarly, the steady flow process are two types. First one is reversible process, steady flow reversible process. Example for steady flow reversible process, steam boiler process, steam turbine, steam condenser, pumping process, right? These are all coming under the steady flow reversible process. And steady flow irreversible process. Steady flow irreversible process. The steady flow irreversible process example is throttling process. Okay. Dear friends, remember, area below the PV diagram is the non-flow work. Area behind the PV diagram is equal to steady flow work, like this. If I mark a process with PV coordinate system, pressure versus volume coordinate system, the expansion curve I can draw like this. This is the expansion curve. The 1, 2, 2 is expansion curve. If I assume that expansion curve is drawn for a closed system, then area below 1 to 2, that means area 1 to KL1 is the non-flow work. This is the non-flow work. Non-flow work. Right? Let me write that point. This is the non-flow work. But if I assume that the expansion curve is marked for steady flow system, let me mark the expansion curve first. If the expansion curve is assumed to be marked for open system or steady flow system, then the steady flow work equal to area behind the PV diagram. This is the steady flow work. Steady flow work. Because the steady flow work formula equal to minus VdP, whereas the non-flow work formula, non-flow reversible work formula equal to PdV. Since PdV is the non-flow reversible work, area towards the volume coordinate in the PV diagram is the non-flow work. And steady flow work equal to area, steady flow work equal to minus VdP. Therefore, area towards the pressure coordinate is equal to steady flow work. Okay. Then you try to go to the second law of thermodynamics. Under the second law of thermodynamics, you try to practice the problems on, right, class ESE statement, class ESE statement, Kelvin Planck statement, Kelvin Planck statement, Kelvin Planck statement, 1 minute. Then you practice the problems on Carnot cycle, Sadi-Carnot cycle. Also try to practice the questions on refrigerator, heat pump, and heat engine. You try to practice the problems, more problems on these concepts. Similarly, you try to practice the questions on problems on class ESE inequality equation. Class ESE inequality equation. So these are the important topics from the second law of thermodynamics. First go through the theory concepts, then try to practice as many as problems that you can do. Okay? Then the most important unit, that is entropy. Okay? Now you try to practice the problems on entropy. First you try to practice the theory concepts like relation between the entropies of solid, liquid and vapor or gas. Solid, liquid and vapor or gas, you can say gas. Then you try to practice the problems on, different entropy problems on different non-flow process. Problems on different non-flow process. Then try to practice the problems on entropy change between the sources like hot source and cold source. Similarly, try to practice the problems on entropy change between source and body. Try to practice entropy change due to mixing process. Entropy change in the mixing process. Entropy change in the mixing process. Also try to practice entropy change for the universe. Entropy change problems. Entropy change on universe. These are the important concepts on entropy. Okay? Then you try to go through the important concepts like corollaries of corollaries of first law of thermodynamics. First law of thermodynamics. Corollaries means achievements. Similarly, corollaries of second law of thermodynamics. There are 4 corollaries from the each law. Try to go through those 4 corollaries of both first law of thermodynamics and second law of thermodynamics. Okay. Similarly, right, you take the another unit called availability. Availability. You try to practice the theory and problems for availability for a closed system, and availability for an open system like steady flow system. Then you try to practice the problems on Gauss-Todel theorem, Try to practice the problems on Gauss-Todel theorem. Try to practice the problems on second law efficiency. Second law efficiency. Second law efficiency for different equipment like compressor, turbine, refrigerator, the heat exchanger like radiator, etc. So these are the important concepts for availability. You try to practice the problems, right, as many as problems, right, for availability for closed system, availability of the steady flow system, problems on Gauss-Todel theorem, and problems on second law efficiency. Okay. Then the other important unit is properties of pure substances. You try to practice theory concepts first, right, like TV diagram, PV diagram for the properties of pure materials, TH diagram, TS diagram, and Molar diagram is also called HS diagram. You try to practice all these diagrams, right? Theory concepts are very, very important for the properties of pure materials. Then you try to practice the problems. Numericals. Very, very important. Then you try to go through the important concepts like triple point state, sublimation, right, freezing, evaporation, and you try to go through the problems on Clausius Clapeyron equation. Clausius Clapeyron equation. Try to solve the problems on Clausius Clapeyron equation. Don't get confused between the Clausius inequality equation, Clausius Clapeyron equation. Then you try to practice some problems on calorimeter. Problems on calorimeters. You know, calorimeter is used for measuring the dryness fraction of the steam. You try to practice some problems on calorimeters also. Okay. Then the most important unit is air cycles. This is very, very important. 2 marks question can be expected from the air cycles. Under air cycles, you need to practice both theory and numericals on Otto cycle, theory and problems on Otto cycle. The second one, diesel cycle, then dual cycle, next one, Stirling cycle, Stirling cycle. The next one, erection cycle, and Lenoir cycle. On all these cycles, you try to practice both theory and numericals. Very, very important. Numericals. Theory and numericals. Among all these cycles, most important cycle is Otto cycle. Okay, then you try to practice the theory concepts on comparison between three cycles, namely Otto, diesel and dual cycles on case 1 for same compression ratio and heat input. The case 2 for same compression ratio and heat rejection. Case 3 for same maximum pressure and heat input. Fourth case, case 4 for same maximum pressure and maximum temperature. So this theory is very, very important. Comparison between three cycles, right, based on the same compression ratio and heat input, same compression ratio and heat rejection, for same maximum pressure and heat input, and for same maximum pressure and maximum temperature. Okay, then right, you try to start the gas turbine cycles, very, very important. Under the gas turbine cycles, you need to practice. These are all the topics these are common topics for both GATE and ESE, right? From the thermal part, thermodynamics part, right? So from the gas turbine cycles, Brayton cycle, and second one, Atkinson cycle. You know, Atkinson cycle is the theoretical cycle for constant volume gas turbine power plant, whereas Brayton cycle is the theoretical cycle for constant pressure gas turbine power plant. Then you try to practice the optimum pressure ratio, theory and numericals for optimum pressure ratio, and try to practice the theory and problems for methods to improve the performance of the Brayton cycle. Like, you know, there are different methods, namely regeneration, reheating, and intercooling. You try to practice both theory and numericals for the methods of improving the performance of a Brayton cycle or gas turbine power plant, namely regeneration, reheating and intercooling. Okay, then I try to start the Rankine cycle, right? Rankine cycle, the TS diagram for Rankine cycle, then you try to go through the theory and numericals for the Carnot vapor cycle, try to practice the problems on regeneration and reheating, you try to practice the problems on regeneration. You know, regenerations are two types. First one, practical regeneration, ideal regeneration cycle efficiency equal to Carnot cycle efficiency only. Again, these practical regeneration systems are two types. First one, open feed water heater mechanism. Second one, closed feed water heater mechanism. You try to practice the problems on particularly open feed water heater mechanism, right? Those who are preparing for gate, open feed water heater mechanism is sufficient. Those who are preparing for both gate and ESE, in addition to open feed water heater mechanism, you try to practice the problems on closed feed water heater mechanism also. Okay, then the next concept, psychrometry. You try to practice the theory and numericals on different terminology for psychrometry. Terminology for psychrometry. Terminology for psychrometry like dry bulb temperature, wet bulb temperature, dew point temperature, specific humidity. Theory and problems both are important. Specific humidity, relative humidity, and adiabatic saturation process. Try to practice relative humidity and degree of saturation also. Try to practice the psychrometric chart. You are finding different lines with psychrometric chart. Try to identify what is the horizontal line, what is the vertical line, what is the 30 degrees inclined line, what is the 60 degrees inclined line, what are the curved lines, what is the wet bulb temperature, like that. Psychrometric chart and psychrometric process. Problems on psychrometric process very, very important. Psychrometric process like sensible heating, sensible cooling, humidification, similarly dehumidification, then cooling and humidification, cooling and dehumidification, cooling and dehumidification, heating and humidification, heating and dehumidification, adiabatic mixing of air streams, adiabatic mixing of air streams. So try to practice both theory and numericals on this psychrometric process. Okay. Then the next unit, refrigeration. Refrigeration. Under refrigeration, right? Air refrigeration cycles for the gate. Under air refrigeration cycles. Under air refrigeration cycles, you have only two cycles under gate. First one is reversed Carnot cycle. Reversed Carnot cycle. Second one is Bell-Coleman cycle. Gate point of view, aircraft refrigeration cycles need not be studied. But those students who are preparing for ESE, in addition to these air refrigeration cycles, you need to study all 6 aircraft refrigeration cycle, like simple aircraft refrigeration without evaporative cooling, with evaporative cooling, bootstrap air refrigeration system without evaporative cooling, with evaporative cooling, reduced ambient type aircraft refrigeration, regenerative type aircraft refrigeration. Those are all coming under aircraft refrigeration systems, needed only for those students who are preparing for the ESE exam. Okay. Then the vapor compression refrigeration. This refrigeration unit is very, very important. Compulsory 2 marks. From the refrigeration part, compulsory 2 marks. So from the vapor compression refrigeration system, you need to study simple vapor compression refrigerant system, actual vapor compression refrigerant system, what is the meaning of dry compression, what is the meaning of wet compression, what is the meaning of superheated compression, what is the effect of subcooling, what is the effect of superheating, what is the effect of liquid vapor regeneration, what is the effect of condensation pressure, what is the effect of evaporation pressure. All this to be studied for the vapor compression refrigeration system, right? Let me write those points, right? So effect of condenser and evaporator pressures and performance of the system. Similarly, effect of subcooling. Effect of subcooling or undercooling. Effect of superheating. Effect of superheating. You try to practice more problems on refrigeration, because from the refrigeration compulsory 2 marks can be expected. Okay. Then vapor absorption refrigeration system. Vapor absorption refrigeration system. Vapor absorption refrigeration system. Gate point of view, only simple vapor absorption refrigeration system is sufficient. For ESE point of view, in addition to simple VAR system, vapor absorption refrigeration system, you need to practice actual vapor absorption refrigeration system, lithium bromide vapor absorption system, Electrolux vapor absorption system. But for gate point of view, simple vapor absorption, let me write it. Simple vapor absorption refrigeration system is sufficient, right? Those who are preparing for ESE exam, in addition to simple vapor absorption refrigeration system, you try to go through the actual vapor absorption refrigeration system, lithium bromide vapor absorption refrigeration system, Electrolux vapor absorption refrigeration system. Okay. Then right, reciprocating compressor, right? You try to practice the questions on classification. Try to go through the theory concept of classification of compressors. Classification of compressors. Then single acting and double acting compressors. Double acting compressors. Double acting compressors. Single stage and multi-stage compressors. Problems on volumetric efficiency. Problems on volumetric efficiency. Problems on volumetric efficiency. And the condition for very, very important, condition for optimum intercooling. These are the important concepts for the reciprocating compressor. Dear friends, remember, reciprocating compressors sufficient for GATE students. Whereas for the ESE students, those who are preparing for ESE, in addition to reciprocating compressors, you need to practice all rotary compressors like Roots blower, centrifugal compressor, axial flow compressor. But GATE point of view, just reciprocating compressors enough. Okay. Then thermodynamic property relations. Under this course, you try to practice Maxwell relations. You try to practice TDS equations. You try to practice the TP diagram, temperature versus pressure diagram for throttling process. And try to practice the Joule-Thomson coefficient, mu J T equal to dou T by dou P at constant enthalpy. Right? Joule-Thomson coefficient for real gas, Joule-Thomson coefficient for ideal gas, what is the meaning of inversion point, and what is the Joule-Thomson coefficient for warming process, what is the Joule-Thomson coefficient for cooling process, and what is the meaning of inversion curve, etc. Or what is the maximum and minimum inversion temperature limits for a particular kind of real gas or refrigerant. Okay. Then last topic for the GATE exam, right? GATE exam point of view in thermal is steam turbines, very, very important. Under steam turbines, you practice steam nozzles. Compulsory 2 marks can be expected. 2 marks can be expected from the steam turbines. GATE exam point of view, steam nozzles, different nozzles like converging nozzle, diverging nozzle, converging diverging nozzle, converging nozzle, converging nozzle, diverging nozzle, converging diverging nozzle. What is the difference between the nozzle and diffuser? Difference between nozzle and diffuser. Difference between the nozzle and diffuser. Next, what is the meaning of isentropic flow? Isentropic flow. Isentropic flow. And what is the meaning of choked flow? What is the meaning of metastable flow? metastable flow. And theory concepts for the nozzle flow for design pressure, nozzle flow for design pressure, etc. Then the problems, theory and problems on impulse turbines like a D-level turbine, impulse turbine like D-level turbines, and compounding mechanism of impulse turbines, There are different compoundings like velocity compounding, pressure compounding, and pressure velocity compounding. Then reaction turbine, a condition for maximum efficiency, Then reaction turbine like Parsons reaction turbine, and what is the meaning of 50% reaction turbine? Condition for maximum efficiency, condition for maximum efficiency of impulse turbine, condition for maximum efficiency of the reaction turbine. And what is the geometric shape of the impulse turbine blade, what is the geometric shape of the reaction turbine blade, what is the meaning of reheating, what is the meaning of internal efficiency, and how many types of governing mechanisms are there with steam turbines. All these concepts are very, very important. You try to go through all the theory concepts and numericals for the steam turbines. Okay. So with this, dear students, the gate thermodynamics can be concluded. Okay. Then in addition to the thermodynamics, those students who are preparing for ESE exam needs to practice power plant engineering. Okay. For the power plant engineering, the best book is Power Plant Engineering by P.K. Nag. Dear friends, you try to practice the concepts like steam boilers, steam turbines, steam condensers, or Rankine cycle. From the Thermodynamics P.K. Nag also you can find the practice the Rankine cycle. You try to practice and gas turbine power plants. Of course, Rankine cycle you can practice from the Thermodynamics by P.K. Nag also. So you try to practice these units from the power plant engineering by P.K. Nag, those who are preparing for ESE exam. Steam boilers, steam turbines, steam condensers, gas turbine power plants. You try to practice from this. In addition to this, right, there are other topics like centrifugal compression. Centrifugal compressors part is not available from the power plant engineering by P.K. Nag. So centrifugal compressors, axial flow compressors, and jet propulsion system, you try to practice from this textbook, Engineering Thermodynamics by D.S. Kumar. You try to practice these three concepts like axial flow compressor, centrifugal flow compressor, jet propulsion system from Engineering Thermodynamics by D.S. Kumar. So these are the topics which are extra right, for the ESE students under power plant engineering. Okay. In addition to this power plant engineering, you need to practice the refrigeration and air conditioning also. The best book for refrigeration and air conditioning, CP Arora. CP Arora. The title is refrigeration and air conditioning only. So this is also additional subject for the students who are preparing for ESE. Under this refrigeration and air conditioning, you need to practice all refrigeration systems like aircraft refrigeration, vapor absorption refrigeration, cascade refrigeration, thermoelectric refrigeration, refrigeration equipments like compressor, condenser, expander, evaporator, capillary tube. Then you need to practice refrigerants, steam jet refrigeration. These are all the additional topics from the refrigeration which are required for only ESE exam point of view. Then you try to practice the air conditioning, right? Duct design and heating and cooling loads in addition to psychrometry. Psychrometry part already covered under thermodynamics. Whatever the extra topics are there, those topics you try to practice from this textbook. That. So then the other subject which is required for those students who are exclusively preparing for EX exam, that is IC engines, internal combustion engines. Gate point of view, under IC engines only cycles are included, right? So for the IC engine, the best book is internal combustion engines by V. Ganeshan. 1 minute. The internal combustion engines by V. Ganeshan. From this textbook, you can find the different engines like spark ignition engines, petrol engine, diesel engines, carburation, the fuel injection system, methods of ignition systems, pollution mechanism, combustion of SI engine, combustion of CA engine, and lubrication system, cooling systems, fuel air cycles, actual air cycles, and combustion chemistry. These are the extra topics which you need to practice, for the ES exam, right, under the course of internal combustion engines, right. So these are the topics you need to practice for the gate thermal and ESE thermal, right. So in the next class, right, on the 11th of this month, we will discuss some important questions from this entire thermal engineering. Okay. With this, my dear friends, I am concluding today's session. So, dear friends, one more important point is there is no specific time for practicing thermal engineering because it is completely independent topic. For example, if you want to study theory of missions, before going to practice the theory of missions, you may be needed to practice the engineering mechanics. It is not something like this. You can start the thermal engineering preparation at any time. Compared to all mechanical engineering subjects, I personally feel that this is very, very important and easy subject also. Right? You try to practice, you try to utilize 100% of your time. Practice is very, very important. Right? All the best and God bless you. Right? Good. God bless you. Good night.